Another one of my projects was to construct a ring around the equator, which, of course, would float freely and could be arrested in its spinning motion by reactionary forces, thus enabling travel at a rate of about 1,000 miles an hour.
The Interplanetary Podcast. The exploration of space for the benefit of all mankind. Your hosts, here in London, Matthew Russell and Jamie Franklin.
Do you know who that was?
Well, it can only be Nikola Tesla.
Yeah, it is Nikola Tesla. Do you know what that is? The first mention of orbital rings back in 1870.
And I love that, recovering from malaria. So clearly in some kind of psychotic state, a little bit.
Yeah, well, I noticed a few of his quotes are things like, you can think clearly when you're sane, but you can think deeply when you're insane.
Wow.
So obviously he was feeling a bit insane with malaria and came up with the concept of orbital rings.
Was he on LSD when he said that one?
No, probably quinine, I would have thought.
Yeah.
Yeah.
A little bit of opium.
Yeah, no, absolutely.
Wow. So, Matt, orbital rings.
I'd not heard of them before until George dragged me in to watch an Isaac Arthur YouTube clip. I love, by the way, I absolutely love Isaac Arthur. It's so broad, his YouTube channel. So guess what?
What?
We've got an interview with him later on in this podcast.
Get out of town.
Yeah, stay tuned.
So, Matt, who is Isaac Arthur? Tell us.
He runs a YouTube channel called Science and Futurism.
Well, we should check it out, I think.
Everyone should check that channel out. It's very, very, very cool indeed.
We'll put a link up on the site.
Absolutely, always. There will be a link in the show notes. So, the orbital rings is a concept not too dissimilar to the space elevator. And it's just basically a massive ring that goes around the Earth. And if you think about it, you could have a ring that just sits there because if one end's falling, the other end is stopping it from falling because it's falling too. So it could just stay there in orbit without anything pushing it up. But that's not quite how it works. I think that's how Tesla kind of saw it working. But you can have it working in a different way by having the whole outer structure of the ring being magnetically held up so it's geostationary rather than in orbital speed.
Got it.
But if you really want to see how that works, you should go to, just watch the Isaac Arthur video because it's the best explanation of it.
There's some cool pictures up of the orbital rings as well, isn't there?
Oh, yeah, there's loads of amazing. Lots. Yeah, there's lots because it turns out that it really is one of the best concepts ever for putting spacecraft up into space.
It sounds expensive, Matt. How much would it cost?
No, it's not. It's not that expensive. That's the weird thing. I mean, we'll get onto that because Isaac Arthur, it's obviously a question we asked Isaac Arthur and he kind of answers it. But if you're really interested, Paul Birch. Now, Paul Birch is a funny guy. So Paul Birch was a fellow of the British Interplanetary Society, and he was the first person that really took orbital rings seriously and wrote 3 very, very detailed papers for the Journal of the British Interplanetary Society. So they can be found volumes 35 and 36 back in 1982. And he does actually price it up in that. And it's really not that expensive at all. Probably about the same expense as the James Webb Telescope, if you can believe that.
Blimey.
Yeah, so, which is crazy, isn't it?
It really is.
But I'll tell you what's funny about Paul Birch. He also stood as a UKIP.
God.
So for those outside of Britain...
I was just starting to like him, Matt.
I still like him. I still love him. He wrote about orbital rings, but he did stand for UKIP. UKIP were the people that essentially caused Brexit, if those outside of the UK are wondering what it is. But there we go. But at the same time, there was a Russian dude called Anatolio Unitsky.
Easy for you to say.
At the same time, 1982, did a similar concept and then published a book about it in 95. But the most recent study has been done by Andrew Merlenberger and P.S. Karthik. And I believe they're students of Anatoly. And they did a paper called The Low Earth Orbit Archipelago, the LEO archipelago. A system of Earth rings for communications, mass transport to space, solar power, and control of global warming.
It's a catchy title.
One of my favourite things about Orbital Rings, you could walk or get a train from Earth to anywhere in the solar system. You could just walk there. You could just walk to the moon if you wanted to.
I love that idea.
I know. So
Matt, should we go for a walk to the moon?
Yeah, totally. A bit later on, after the news, we'll have that interview with Isaac Arthur. I don't just talk about Orbital Rings as well. We go absolutely everywhere with it. So it's just very,
really?
very...
You're going to go deep, aren't you?
We went deep. George joined me and asked a couple of fab questions as well. So
good man.
You need to check it out. News, Jamie. The news.
Well, we should speak about Virgin Galactic,
shouldn't
we?
We just missed that last week. That happened just after we'd recorded the last podcast. So
the test flight of Unity, SpaceShipTwo, SS2.
The pilot was a chap called McKay, and he is obviously sounds Scottish, doesn't it? McKay
does sound Scottish.
Yeah, and he is Scottish and flew for the Royal Air Force, and now is with Virgin Galactic.
Cool.
It looks like that test flight went extremely well, and Sir Richard Branson tweeted, "Space feels tantalisingly close now." Do you know what's really funny? Obviously, we went completely over the top with our voices last week, but
we did.
I've also been listening to a book called Space Barons, which came out a couple of weeks ago, and I've been listening to that on Audible. And every time Richard Branson is sort of saying something in it, the person reading the Audible book attempts a Richard Branson voice. it's quite
unironically.
It's almost like a half-arsed attempt as well. It's just like, oh. But what's funny is, by the way, Americans, Richard Branson's English accent is slightly annoying even to the English.
That's true.
Yeah. So, yeah. But I also noticed that Saudi Arabia invested in Virgin Galactic. They've invested $1 billion into it. But it's not just Virgin Galactic, it's also Virgin's Hyperloop.
This is it. They want to connect its cities, don't they? Yeah. Adjoining countries via a network of Hyperloops. I mean, they are thinking ahead.
Another news story that caught my eye because of a podcast we did with George a few weeks ago, or maybe months ago even, was...
You're going to mention Venus, aren't you?
I am. Is there life in Venus's clouds?
Here we go.
So on Earth, Jamie, from space you can see algae bloom in the ocean.
Correct.
A similar sort of thing is happening in Venus's clouds where dark patches form, and no one's ever really been able to say exactly what the process is that caused these dark clouds. And there is a paper called Venus's Spectral Signatures and the Potential for Life in the Clouds by Limier, Sagnier et al. And it suggests that maybe this is caused by biology.
Wait a minute, Matt. Are you saying what I think you're saying? Are you suggesting that there's life on Venus?
I'm suggesting that there is life in Venus's clouds. There's just a tantalising bit of evidence.
I need to read that paper.
Yeah, it's
Where can we find that, Matt? Can we put a link to it?
I'll put a link to it, definitely. But yeah, if you just type in Venus spectral signatures and the potential for life in the clouds, you can get there. It is really fascinating.
If you type that in, guys, by the way, sorry to interrupt, Matt. If you type that into Google, what also happens crazily is you instantly get a date.
Yeah.
Because they're going to be walking past. They'll probably see you type. They're thinking, hang on, who's this guy?
Who's this?
Hang on. I think I need to be with him.
And it works the other way around. In fact, it's a universal thing.
I was kind of talking about me, but I mean, yeah, sure. I mean, if you want to get a date, plural.
Yeah, so basically they're advocating that we go off to Venus and check it out with some form of airplane balloon thing.
I think we should.
For sample return missions.
Although you're going to have to tell your son George that I still don't want to live there ahead of Mars.
No.
Sorry.
No. Oh, I'll tell you what's really cool.
Go on.
The European Space Agency has done a software update with Mars Express.
Oh, okay.
Which was a probe that arrived at Mars in 2003 on a 2-year mission. but it's still going 15 years later.
15 years going strong. Brilliant.
Yeah. Well, it's not going strong because...
Oh.
No.
Going weak.
It's going weak, yeah. Some of its gyroscopes are failing.
Ooh.
So they sent a software patch to see if they could just extend the lifespan of this very, very important spacecraft till sort of June 2019.
And has it been successful?
I believe it has. Patrick Martin said, "This is certainly the most complex and extensive software rewrite we've done in recent memory."
No, I think he sounds like this, Matt.
This is certainly the most complex and extensive software update and rewrite we've done in recent memory.
Patrick Martin? No, that doesn't sound very Patrick Martin to me.
I just got because it'd been such a long time since we've done a silly voice, you know.
Oh, totally. A quick news item. Jim Green has been announced as NASA's new chief scientist.
Big Jim Green.
Big JG.
Congratulations.
Well done, Jim. SpaceX have been cleared of the $3.5 billion Zuma failure.
Yes, thankfully.
Even though I don't think it was a failure, I think the whole thing is smoke and mirrors. And
it really is.
And that Zuma did end up in orbit. I mean, this is crazy.
Matt, this is what happens with sensitive spy satellites, you know?
Yeah. So, who knows? Now, get ready to drink, everyone.
Oh, here we go. You're going to mention him, aren't you?
I am. Elon Musk has been showing off a new tooling for the BFR spaceship. So, this was an epic tweet where he had a car next to an enormous metal drum. And it's a funny looking thing because I think it's a huge drum where they're going to weave the carbon fibres around to make the carbon fibre shell of the BFR. So it's actually being made. It's actually being constructed. So that's super cool.
So Matt, is it like a giant 3D printer or not?
Well, it's more like, I'm just trying to think it's like at school when you used to wrap. It's almost like a bit like knitting. It's like crochet in reverse.
Wow.
Or something like
that. I'd like to see it.
Yeah. Like the process of how you make pom-poms. I don't know.
Hey, Matt. You know that we're darlings of the European Space Agency.
Mm-hmm.
Can you tell me what's happening with ExoMars, please?
ExoMars. So, we mentioned a few weeks ago how it had finished its aero-braking manoeuvres.
Yes.
It spent ages literally using its surface area to slow down in the Martian atmosphere, in the thin Martian atmosphere. It's done it now. So it's just about to start to do its proper science. So it's got a couple of... it's also got a bit of software updates and calibration to do. And then...
Standard.
And then it's going to be looking for life.
Ooh.
It actually, we actually might find life using ExoMars. It might be that we see just biosignatures. Basically, it's the trace gas orbiter. So it's looking for trace gases in the atmosphere that could...
Matt, can you imagine the buzz if it finds it?
It would be a buzz and a half, wouldn't it?
Like nothing else, surely.
Go, ESA. Go, ESA.
Come on, you can do it.
Come on. So, X-37B, Jamie, the secretive shuttle.
It's one of my favourites.
We covered the launch back in September when it went up on a Falcon 9, which was incredible in itself, the fact that SpaceX have stolen that contract. It's been up there for 200 days now. That's 200 days it's been up there, secretively flying around, testing EM drive, no doubt.
Oh, typical.
So anyway, I'm going to quickly run through your the launches. We had an Ariane 5 just after we spoke last week.
That's right.
Totally successful. Had a British satellite on there called HILAS 4.
Get in.
The Chinese did a quick, unexpected Long March 4C launch.
Uh-huh.
India did another PSLV XL launch, this time successful. We've still not heard whether their GSAT-6 has been recovered. I don't think it has. And coming up, really, really exciting. We have an Atlas V launch, followed by possibly the most exciting launch of the month, which is Falcon 9 taking up TESS.
TESS
is really, I guess, Kepler's replacement. It's looking for more exoplanets.
And by TESS, you mean the Transiting Exoplanet Survey Satellite?
Exactly. So it's looking for planets that transit in front of their star. And it's going to cover an area 400 times larger than that of the Kepler mission.
Matt, I often think that I transit in front of you, my star.
Oh, that's beautiful, Jamie.
It's lovely, isn't it?
I'm not quite sure what it means.
No, nor do I, but it's Friday, and I'm feeling emotional.
I'm feeling the emotion there.
Let's hope it filters through everyone's ears into their own souls.
Whoa.
Enjoy that.
Here's something that will fill your soul full of wonderment.
Oh, yeah.
Is that TESS is going to go into an orbit called P/2, and it's an orbit that's never been used before.
Really?
And
that's crazy. I'd like to see that in motion.
But it's one of those orbits that remains stable for decades, so it just means that TESS will be in a sort of temperature range that will remain stable, and we'll be able to just get on with doing all that science stuff.
Apogee and perigee
live together in perfect resonance.
Oh dear. We should add that to this space songs list.
Electron might be taking off as well this week, which will be its first commercial launch after the successful still testing launch. So,
really?
Yeah, so that will be exciting. And we also have a Proton M with a Breeze M carrying some military communication satellite for the Ruskies. Go Ruskies.
I mean, there may be tension on Earth,
but not in space.
But there's still harmony in space.
Yeah.
I think there's something to be learnt there, Matthew.
There is, isn't there?
Can everyone just stop fighting?
Now, I should imagine that people like Jake over at We Martians are getting excited for NASA's InSight spacecraft.
Oh, massively. I'm so jealous.
Yeah, so that we'll talk about that when it gets nearer, but May the 5th, that will be the first time that an interplanetary launch has taken off from America's west coast.
Oh, that's so exciting.
So be excited, California eyes.
Oh, well, do you know what, Matt? I watched a video this morning before I got up to have breakfast because I thought, you know what I haven't watched in a while? PBS Space Time.
Oh, beautiful show.
And I watched the episode that was talking about the death of the sun.
That's a good one.
It was really good. I really enjoyed it. I was thinking yesterday about how long we've got left, Matt. Mm-hmm. And by we, I mean the human race. Mm-hmm. We've got about 5 billion years left of the sun.
I think we're
going to be all right.
Even if they cure death, we're likely to die in an accident before then.
Yeah, exactly. I'm not sure we'll still be around as a race by the time it gets to a white dwarf, Matt.
Yes. Have you also noticed, Jamie, that really good hosts of science spacey kind of things are called Matt? Anyway, moving on. Let's have a listen to one that isn't called Matt. Let's listen to one called Isaac Arthur.
Here we go.
This is so epic. Écoutez. Hello, Isaac.
Hi, Matt. Thanks for having me on.
It's absolutely our pleasure. So my first question is, can you tell us a little bit about your background and how you became so crazy clever?
Oh, well, I started off, both of my parents met when in college as physics majors, so probably unsurprisingly I had an early interest in it as a kid. Went to college for it, and then went into the military after I got out of that, went the civil service side of things, and the channel just kind of started as a hobby, and now it's way past hobby stage, so I spend way more time on the channel these days than anything else, but that's essentially the background, pretty straightforward. Degree was in physics, so...
So the one thing that really caught our attention, and this is what George came up to me, said, you've got to see Isaac Arthur's episode on Orbital Rings. And we was wondering if you could tell us a little bit more about Orbital Rings, because that was one thing that we thought was just so cool.
Oh, right. Well, I always say of Orbital Rings, they're basically the granddaddy of space launch systems. They're not something you'd start off with in the near term, though there are some ways you might be able to do a very small one early on. It's really more when you hit the stage where you want to be transporting not just, maybe a dozen astronauts a week or even, dozens a day, but when you're looking to be able to move tens of thousands of people up to and down from space every single day. That's when you build the orbital ring. And it's an interesting concept because it's a little bit like a space elevator in the sense that it's geostationary, but it cheats. You've got an exterior ring that just comes along with the planet, moving along with it. And you also have an interior to that ring that's actually moving at greater than orbital speeds. Their net momentum, their net angular momentum, is what you need to be in orbit at whatever height in orbit they're at. But it appears as a stationary ring that's got inside that's spinning around even faster than a satellite would. And that's what keeps it afloat. Some sort of magnetic material on the inside spinning around. That could be particles or just a simple copper wire with a charge and magnetic around it that floats the rest of the ring around it or above it. And that's completely stationary, and that could be, just 100 miles off the ground or even less, and you can run tethers up to that rather than needing the really super strong materials you need for a classic space elevator. The big problem with the space elevator is that it has to actually hang about, tens of thousands of kilometers long, and that's very hard on any material. Even something like graphene, if we can learn to mass produce that really well, could only barely do that if you tapered it, if you made it wider at the top than the bottom. And that's just very dubious as to whether or not you could actually ever get that working in a practical and feasible way. Whereas the orbital ring is, again, that's only maybe 100 miles off the ground tops, and you could even have it lower, just hovering just above mountain level. And at that point, it's not a very big issue to run even something like Kevlar up to it, as opposed to any kind of high-tech super material like graphene.
So what makes the orbital ring have less hype and less funding into it than the space elevator?
I'm not too sure. It was proposed by Paul Birch decades ago, and in fact, he passed on quite some time ago. And it's part of the active support concepts we see from things like that in the Lofstrom loop or mass drivers. And I think maybe that's part of why it's got a constant power supply rather than being a rigid object that you can crawl your way up like a space elevator is. But I think that when we started getting the various nanomaterials, carbon nanotubes and buckyballs in the 90s, that people started saying to themselves, maybe we could build an actual space elevator one day. And so concepts like the orbital ring got put on a shelf, which is unfortunate because in most regards it's actually quite superior to a space elevator.
Is there a costing? Has anyone actually done a feasibility study and costed it up, what it would actually cost to put an orbital ring up?
Yes, Paul Birch did do one, and unfortunately those numbers are so out of date. This was done in the late 70s, early 80s, that I wouldn't want to try to put it into modern terms, but it wasn't super expensive for the very baseline system. The idea being that you just basically put a very thin copper wire around the whole planet, which might weigh thousands of tons tops, and the sheath around it, and that's your basic system, which you then pour other material up and avoid the launch costs on. But I tend to be a little bit dubious about whether or not that would be sturdy enough to actually do much lifting. That's more of an engineering thing I can't answer, so I always think of that as more of a 22nd century thing for when you're doing a lot of throughput. But it is viable potentially for a forced launch system. It's just the costs are all going to depend on a lot of variables that I'm not really good to be able to talk about. They've changed too much since his time. Anybody who wants to read that, though, that would be at the Paul Birch archive. You can find it at Orion's Arm. It's one of the papers, and he does go through a lot of the technical details. But 40 years of new technology has probably made it much cheaper.
You have a series about these megastructures on your YouTube channel. What would you say is going to be built first and when?
If I had to guess as the first one, just because SpaceX is doing so well these days, I would tend to think your first megastructure would probably be something along the lines of the Gateway Foundation station. That's quite large. I don't know if I'd really constitute that as a megastructure, but a much bigger space station of that variety. And then the question is, do we start sourcing materials off the moon, or is that too far ahead yet? And other options, I don't see the space elevator in the next 50 years just because we're just not there materials-wise yet. You could see a mass drive or something like the Startram system, if you're familiar with that at all.
Give us a rundown on that.
Startram is a basic mass driver concept where you set up a very long rail, one that's long enough to handle the kind of acceleration a human can take while still getting them up to the right speed. And with that, you can build a rail that might be 30 kilometers long for basic material launches, or thousands of kilometers long and elevated so the end is right over the top of the atmosphere. And you just run down that like it's a train. Big, hollow bullet train you go down. Think of the Hyperloop, only bigger and trickier to build.
Yeah.
A more modest version of that would probably be using something in conjunction with something like a skyhook, which is technology we can do now too. It's basically an abridged space elevator.
I mean, I'm really struck, as particularly considering we've just had the 50th anniversary of Apollo 6, and I'm really struck the fact that Saturn V is still the most powerful rocket, and it's still, the rocket equation is still the thing that's really constraining us to Earth. And I really like your channel in the fact that it comes up with some alternatives. How long do you think we will be constrained by the rocket equation?
The rest of time, probably. I mean, that's the thing is to push yourself along, you need to push something out behind you. And I do not see that one. I mean, even things like the orbital ring of the launch loop, they're still using conservation momentum. It's just you don't have to carry your fuel with you. If you want to get far away from this planet, you either have to use something that is sending you out energy as you go, like beaming lasers out to power an ion drive, or setting up a solar sail that you're pushing on, like Project Starshot, or you have to come up with some completely new physics, because you have to have some place to change that momentum over with. And obviously, if somebody can find a way around that, something like the EM drive actually turns out to work and be non-inertial, then we get around it. But I have to admit, I'm not too optimistic on that score.
No, I was just about to say, do you actually think that EM drive is going to pan out? Because I'm more than dubious.
I was very skeptical about it, and I won't say that I'm not very skeptical about it still. I do not expect it to work like it's been advertised. But there's enough there to say that something interesting is going on that is worthy of additional study. I would not expect to get any new physics out of it, but we might get some caveats, and we might all turn out to be wrong. And it could all just turn out to be a lab error, but that's part of science. Sometimes you got to run those down. Being wrong 9 times out of 10 still means 1 time out of 10 you have something new and fun.
Yeah, no, absolutely. Do you see a possibility of something like nuclear propulsion making a return in, let's say, the next 100 years?
Oh, absolutely. I mean, it just depends on what type of nuclear we're talking about. Hopefully it'll be fusion, but there's a lot of options for classic fission drives. I don't expect to see too much use in the immediate vicinity of Earth, just because I suspect many people will object to, even a nuclear thermal rocket for space launch. But especially if you can source the materials, the radioactive materials from off Earth itself, it's such an ideal way to get energy much more compactly than chemical fuels will allow. So for interplanetary travel, absolutely. But I don't see it having too much of a role, at least fission-based ones, for near-Earth applications.
Do you have a favourite method of getting objects off Earth up into space in terms of any of the stuff that you've looked at, and whether it's futuristic or not?
The orbital ring is just my favourite, end of story. It's not something we can use too soon, probably, but it's right up there, and I'd say my second runner-up would be the Lofstrom loop.
Can you give us a little bit of a rundown on that one?
Okay. The Lofstrom loop is another example of an active support system. The basic idea is you take a track, but instead of starting on the ground and ending in the atmosphere, you just lift the entire thing up to about 80 kilometers in the air, enough so that it's still being covered by the atmosphere against micrometeors. And it's a big, long launch track that you just run down magnetically. What's actually going on inside that, though, is it's shooting out streams of particles or a chain of metal that is moving very fast and being magnetically propelled along. And that's actually what you use to steal your own momentum off of to launch the ship. But it's just a big, long, I wouldn't say straight because it goes with the planet, but more or less straight, big, long launch loop that you build in the ocean, a couple 1,000 kilometers long, and float up there. And it sounds insane, but Keith Lofstrom has worked out all the math on it and all the engineering very thoroughly. And he could actually potentially be built for as little as $10 billion.
Well, that seems... Isn't that cheaper than SLS?
But, I mean, just assuming typical government contracting and R&D, figure if it looks like it's going to cost 10, it'll probably end up costing 5 times that. So
Yeah, well, that's definitely the case with James Webb and SLS.
And with all these things, it's how much do you use them? Are you using them enough to cover the cost and the maintenance? And do we do, say, $5 billion worth of launches a year? Because that might be the maintenance on something like that.
Yeah, I'm interested to know what you think, because obviously we're over here in good old Blighty. What did you think of the Skylon project? Did you think do you think that could go anywhere?
I am not as familiar with that as I would like to be. There was an earlier version of that called Hastel, which actually is designed to have the plane fly up and link up to a skyhook, so you don't have to get as much speed. I'm trying to remember what I actually specifically recall about Skylon. Similar concept, though. It's dubious if something like that can actually get up to orbital speed on its own. It might be able to, but it doesn't actually have to if you have something like a skyhook in place, especially a regenerative one using electrodynamic tethering that can catch it at a few, about half orbital speed and then just pull it up the rest of the way.
The skyhook, do you really think that has a real feasibility then? Do you think that might be one of the first extraordinary routes into space to come into existence?
I think that it genuinely does. It all don't, basic concept, for those who aren't familiar with it, is it's a lot like a space elevator, although we probably spin it while it was going. And there's actually an episode on this for anyone who wants to see the graphics on that. But it uses the same tensile strength thing that a space elevator has going on, but you don't need as much of it, because it is actually orbiting at a slightly slower speed than it should be based on its bottom height. And if that thing is spinning the opposite direction, your link-up speed is much lower. And at that point, you just steal momentum off that skyhook. But if that skyhook has solar panels on it and is engaged in electrodynamic tethering, it can slowly regenerate its own momentum between pickups and hooks, so that you've got a platform that lets you launch into space for maybe 5,000 kilometers launch velocity, 5,000 kms launch velocity instead of the typical 8.
Yeah.
And I think that's definitely on the potential table because, again, it is the same concept as a space elevator, but doesn't need nearly as much tensile strength to be useful. Theoretically, you could do it with something just like Kevlar or Xylon, but it wouldn't be very long in a case like that. If you can't quite make a space elevator, but you're in that range with something like graphene, then a skyhook is a great alternative.
With the next, say, 30 years, do you think it's just going to be business as usual? Or do you think we're going to maybe, like you said, with the success of Falcon Heavy, for example, do you think we actually might be seeing the start of at least the capability to look at these bigger structures and more ambitious things that will enter a kind of new Apollo era?
I'm inclined to say yes, but I think a lot of it's going to depend on how things like the BFR do in the next decade or so as they roll out. If they go as well as expected, or at least optimistically expected, I think we will hit that snowball point where the launch costs have dropped enough in terms of both the specific cost and the volume we can launch up there, that we will start seeing some much more ambitious projects and enthusiasm picking back up. Right now, for the last almost 40 years now, we've had a kind of a climate that says, oh, in 20 years we'll do this, and it keeps being 20 years and it never happens. And the public's starting to get just a little jaded about that, but we're going to have to see. If those launch costs come down, I think we will hit a snowball point, and I think the public would be more than happy to start funding Mars trips and moon bases if they can be done reasonably safe and economical. And if you got launch costs down to under $1,000 a kilogram, they absolutely can be. At that point, you can start doing a moon base or some large orbital stations to replace the International Space Station. And I think that could be the snowball point that we've all been hoping for, but hasn't quite materialized in the last 30, 40 years.
Yeah, do you think that there's also this whole idea of convergent technologies that we're going to have? Because I mean, this is what I really love about your channel. It's so diverse, and one I watched the other day was about advanced metamaterials, and so you've got all these different. You've got all these different convergent technologies like metamaterials and different new power sources, etc., etc. Do you think that we could actually have a black swan moment?
It's potentially quite... I mean, you have a lot of technologies working together to improve things. Even something totally unrelated, like a fusion plant that you could never put in a spaceship, but it's still there. could suddenly have such a huge economic impact on just the general infrastructure that all of a sudden spaceflight becomes very possible, even if you could never actually put one of these in a ship. And with so many of these things, they have the potential to either boost up your infrastructure and economy or to directly impact some aspect of the manufacturing that, and with so many of them potentially in play, yeah, I think that we would. I mean, if we had to do the Apollo mission again today, we could do it cheaper and better. There's just not much point going there just for rocket, just for more moon rocks. Or, I think that we are going to see, improvements in automation, improvements in the basic stuff we can manufacture, as well as how cheaply we can manufacture them. And so even if we don't get any of the really good space technologies that are kind of on the horizon now, I suspect we'll probably hit that snowball point in the next 30 to 40 years of the worst case scenario anyway. There's just too much stuff, as you say, converging out there to make it easier.
Now, one thing that we definitely can't let you go without talking about first is alien civilizations, because your section on that is just so cool. What's your favorite of the alien civilizations that you've talked about on your channel? Do you have one of the different types?
Well, it's always kind of weird for me, is because I'm kind of a notorious skeptic about there being any alien civilizations, even anywhere in our own galaxy or its neighbors. One of the things we talk about on the channel so much is if they're there are certain behaviors we'd expect from them, and we're not seeing them, so we tend to think they probably don't exist. I don't know that I really have a favorite alien civilization design. For all that I'm a skeptic about it, obviously it's something I really enjoy speculating about. I say the Fermi paradox is one of those things where I'd always be glad to be proven wrong. But I think it's less that we have a favorite one on the channel as they are ones we particularly enjoy teasing because, as you say, there's so many of these examples of hypothetical science fiction civilizations people will use with the Fermi paradox to try to explain why they're not contacting us. And we will poke at those and pick at those and say, these really don't work unless they are really smug or really genocidal or really paranoid. And I have to admit, I'm particularly fond of the smug. I think we did one smug aliens and stupid aliens. Those were my favorite ones to do. So we have all this wonderful technology, but we're not going to share it for your own good.
I never buy that one. Yeah, that there's someone looking down and going, yeah, they're not quite ready yet. Because that never happens.
I could kind of maybe see that, but the one I always have as a favorite for the movies is when they come and land and tell us what a bad job we've been doing and how we're destroying our own planet, and you say, wait a minute, you have technologies that would fix any of these problems. Yes, we absolutely do. And you're complaining to us about how we're not doing things right. Yes. Why don't you share some of those? And this would seem like a way to fix the problem. No, we're going to commit genocide against you instead. I'm not sure that really makes sense. It doesn't have to.
Well, maybe it's only through aggressive behaviour that you become, technologically advanced. Maybe that's what the author is trying to say.
It could, I'm never too. To me, with so many of the Fermi paradox solutions, it always seems like someone had a particular science fiction show they were very fond of. And because I know this was the case with me, is I did not like the solutions I was coming up with because I was a big Star Trek and Doctor Who fan. And those aliens are everywhere and mostly friendly-ish. Mine's like the Daleks or the Borg. So it was very disappointing to kind of look at things and say, none of these really quite fit. And I think a lot of folks, they have that particular science fiction, theory they fell in love with or alien conspiracy theory they fell in love with, and they're going to defend that to the last, no matter what you present. They say, no, we can make it here. What if they did this? What if they did that? You say, well, it'd be weird if they did that. Why are they doing that?
What about our own civilization? What about the human civilization? Where do you see it going? Or don't you? Perhaps we're going to global warming's it for us.
Well, I think we're going to find a way to solve pretty much all of our problems. I don't tend to see us converging towards any particular type of utopia, though, just because I think, say in space we become this much more enlightened civilization. I say, well, I bet some people will. And I bet you have 10 different factions that all agree they are the most enlightened entirely, and those other guys are not. And I think you'd have other people who said, oh, I'm going to be like the space Amish, and I'm going to stick with the technology I love and like. So I tend to think that there is a very big future out there for mankind, that we will survive anything apocalyptic. But I don't really see it going towards any kind of unification. I think, if anything, we're going to spread out, and you check back in the galaxy in a million years, and you say, "Oh, look, they were the aliens. It's just they're us." So this planet here, the people decide that long ago they wanted to have 4 legs, and
Yeah. So, what do you think about AIs? And is it a danger?
Oh, absolutely. Probably the most dangerous thing you could imagine, because, I mean, again, it's a horrible Fermi paradox solution because you're not getting rid of intelligence, you're just replacing it. But in terms of potential threats to humanity, AI is right up there with nuclear as one of those things where it has the potential to be amazing for us, to be one of the greatest things that ever happened to us, or to destroy everything. So with AI, the only thing I usually just have on that is you can make an argument that even humans nowadays are essentially an artificial intelligence. And so you have these pathways to making artificial intelligence, 3 major ones. One is that you basically just copy humans. Either you literally take a picture of a human mind and put it on a computer, which I normally would not call an artificial intelligence, or you're copying and tweaking a bit, or you've got one where you've programmed it up every single line of code and it's totally controllable. Or you have one where you get a basic self-learning algorithm and let it run its way up through knowledge that way. And each of those is so entirely different that there's at least as much difference between those 3 types as there are a human and an oak tree. It's just an entirely different type of life form. And you never know what's going to motivate something like that. If it's fairly human, then you tend to know what kind of motivations it has. If you've programmed every line, you know that too. If it's self-learning, it's basically a completely new life form, and it might be very hostile to us, or it might say, "Oh no, I'm a human. You're the guys who raised me. I'm a human completely." And there's so much room for things to go wrong there. I think the paperclip optimizer is one of the favorite examples of that, where you just got a factory that makes paperclips, so that's all it's about is more paperclips. And I think we were writing one up for a post-scarcity civilization where you have a household computer that is so focused on helping its owner, which unsurprisingly I named Summer, that everything is about protecting Summer, must protect Summer. And it might decide, I need to find out what Summer's guests like to eat so that she's not disappointed in the house party she throws. So while the guest is driving over, because they have privacy settings on their Facebook 2020 page that prevents you from seeing what they like to eat, it hires commandos to raid that person's house to find out what it is that they like to eat, and comes back and says, I found out what she likes to eat. And that sounds completely insane, but if its only focus is that person, or, those paper clips, it's going to act in that fashion. It's not going to see that doesn't make sense. And because to it does. And you can't reason with it and say, no, paper clips are not the most important thing in the universe, because say, no, that's absurd. Of course they are. It could be entirely reasonable. It might like poetry and art and think human civilization is great. And it's going to love people, especially if people can help it make better paper clips. And so AI is basically a crapshoot. If you're lucky, it works out well. And if it does, then you've got amazing options available to you because you have really no bottleneck on production. So you've got a utopia sitting right there. If it doesn't work, you probably won't be around long enough to regret it. So caution is advised.
Yeah, it does scare me a little bit. It scares me especially considering everyone who's a lot cleverer than me, i.e. people like Musk, yourself, etc., seem to all think that it's this really deadly thing. One question I do always think about is that for years I was labouring under the assumption that once you created a powerful enough machine, a powerful enough computer, it would automatically become conscious. But then I realised, where did I get that? Where did I get that premise from? Where do you stand with that? Do you think that consciousness is a sort of really weird animal quirk, or do you think that we could actually create machines with consciousness?
We actually don't know. There's a really good book called Blindsight by Peter Wass that plays around that concept. I won't spoil it here, though. I don't think that if you build a really big computer, it automatically becomes intelligent. But then you have to ask, why did you build that computer that big in the first place? And it was probably to solve human-related problems, which means that it was probably programmed with a good understanding of human thinking, and that could happen. One thing we see a lot in science fiction with fears about AI, which goes back to at least Asimov's time, is this kind of tendency to assume that it happens on accident. And I think that goes in for a lot of science fiction where they see, we just kind of blundered into something. If that happens, yeah, you have potential problems, but that usually isn't how it happens with technology. Typically, we know exactly what we're doing when we make it. And in that respect, I think it's a little bit less of a threat. You're not just going to flick it on one day and it's going to turn into Skynet. You're going to see that coming as a real possibility on the horizon. And it's not going to be something somebody just does in their lab. And so you get all these, government committees looking over and putting safeguards on it. In that respect, I think it's probably a little safer than some of the doomsayers are saying. But at the same time, I usually do count myself as one of those doomsayers. It's something we should approach very carefully.
Well, with all technologies, I always just have the feeling that if there's a technology that's there to be made and to be done, physicists and scientists can't resist doing it because it's there to be kind of done, and it's like you can't put a genie back in the bottle once you have the concept of going, right, yeah, we should create AIs and we've got the technology to do it. There is no stopping it. As in, no amount of legislation is going to stop people from doing it.
That's a possibility, and I think in the long term that's probably true, but I think, maybe we shouldn't just assume. I mean, again, I don't think someone's just going to put one of these together on their home computer one day.
No.
And, it's a lot of computing power, and yes, computers are getting smaller, but we are starting to hit the end of Moore's Law, and I don't think that's going to return. And, when you're running something that big, even if you're trying to do it in your basement, it's going to be using up so much energy and releasing so much heat in the process that you'd probably be able to tell that someone was doing that off the grid, as it were, and be able to send people in to stop them, which means that otherwise it would just be on official computers that are probably being watched over very carefully. So I think you probably could keep that genie in the bottle if you really, really wanted to. And I think this might be an example where we really, really wanted to. So I do not necessarily take it as a given. It's obviously very beneficial to have superhuman intelligence available to you. But it's also sort of thing that has enough potential problems that I could see people getting very hesitant to see it proceed. And there is always the possibility with a lot of these things that they'll reach the point where technology is so nice and makes life so easy that people will say, that really is enough. We are this close to having something that could devastate us. So we're going to say this point is it for technology. No more research in these fields past that, so that it was at least enough far back that nobody on their own could realistically do it in their own lifetime. And that's another of those potential Fermi paradox solutions where people have decided that the risk is too great and they maintain that. But I don't see that being able to last in the long term. Maybe for a century or two, but not for thousands or millions or billions of years. And those are the kind of timelines you have to contemplate for that particular paradox.
Do you really think that Moore's law's gone away? Because don't you think that we could enter new computing paradigms, like quantum computing, for example?
That just comes down to how many particles they can keep entangled at once. And I mean, it's not ideal for a lot of applications either. If I say Moore's law is dying, the people who already believe that will nod their heads and say, he's probably right. And the people who don't believe that, no matter what I say, they're not going to be convinced. 10, 20 years from now, I might be eating my own hat because they're 100,000 times faster than they are now. But I actually do expect them to start petering out. We'll have to see, though. It's where's the paradigm shift going to happen for something better than semiconductors? But we are at the point where we're pretty much maxed out on semiconductors. And again, we also have the other problem people forget with computing, which is getting rid of the heat. Those computers produce a lot more heat for processing power than a human brain does, for instance. And, all that energy you have to use and all that heat you have to get rid of is one of the things that keeps us from making them too compact. So someone's got to overcome that problem too.
I guess biology overcame that problem. I mean, the human brain's obviously
it took 4 billion years to do it.
Yeah, but you've hit the nail on the head with it when it comes to AI, haven't you? In terms of it doesn't take billions of years because you've not got this annoying procreation thing to worry about. You can run the iterations billions of times a second if you want.
But it probably isn't instantaneous either. There was a tendency to think if you build a computer that's as smart as a human or a little bit smarter, the very next day it's going to give you blueprints for an even better system or upgrades to itself. And to a degree that makes sense, but then you got to think about it. Humanity's been around for hundreds of thousands of years, and probably for most of that time was very interested in finding ways to be smarter. I can't recall anybody actually reinventing a better human recently, with a bigger brain. So
No,
I don't think it's a
that's-
one-man task the AI is just going to achieve the very next day.
I was looking on the internet and saw this thing that Boeing had posted. They had designed a wall inside one of their planes, and it was designed completely by machine learning, as in using evolutionary processes on a computer. So I was thinking maybe in the future that could be used to design future spaceships and megastructures and things like that, and computer programs as well.
I don't know enough about it to really be able to say one way or another. I mean, with Boeing, obviously, if they got something that's doing good materials research, that's mostly doing it on its own. It would be one of those examples where I'd be curious to see how much on its own it was really doing. You get an article for a chatbot that's allegedly being very impressive, and then when you look at it, it's really not Turing compliant. So I'd be curious to see how independently it was doing that before commenting further. But, there is no doubt that smart computing is something we're going to have in the future, even if we don't go all the way to full-blown human-level superhuman AI. And it's already making a lot of impact on a lot of things in terms of improvements. Design is obviously one of those things that we didn't usually think of as computers doing that are turning out to be quite useful for them. But it's all going to turn out to be a question of how does it play out as we improve it. And it's so hard to guess on those that I usually just opt to join everybody else and saying I really don't know.
I can't let you go without talking about interstellar travel. What about interstellar travel? Do you think that's feasible? What kind of timescales are we looking at for reasonable interstellar travel? And do you think actually it'll involve humans ever?
I think that it will. There's a few pathways to doing this, and the simplest design that we've had for quite some time is actually nuclear propulsion with shooting nuclear bombs out the back of the thing and pushing along Project Orion and Daedalus. And of course, we have things like Starshot that have been being discussed for pushing things with laser beams, and we talk about that on the channel a lot too. That can be scaled up potentially. You need, I think, about 1.5 gigawatts per ton to achieve a 1G push. But that's potentially doable. You could have some, 100,000 gigawatt, space-based power grid that's pushing ships along to near-light speeds. They have to slow down when it gets to the other end, though, so you don't want to push that too fast. But there are a lot of options on the table. If you get something like fusion that you can build to any sort of spaceship scale, then you pretty much automatically get interstellar travel with that. As you start building up a solar system and you start getting more solar reliant, if you don't really have fusion, then you automatically get it that way too, just from the ability to push all those laser beams onto things. And I do think that we can see humans moving along. Whether or not the first step would be the, I'm trying to remember, was von Neumann chicken or the Bracewell probe von Neumann chicken. The little space probe that heads out on its own, arrives at the destination, starts building more of itself, and starts building, say, humans from digital samples of their DNA, and just growing them in vats. That's one way to colonize. You head out and you hit a planet, terraform it, and grow your people there. It's not immigration, but it is colonization. And that's something that's definitely on the table, even if we can never make spaceships big enough to carry people around, just seed ships it's called. But I do think we'll be able to move people from point A to point B across the stars without needing fashion-light travel, which I tend to think is impossible.
We had Robert Zubrin on the show a few months ago talking about the seeding ship idea, and he was talking about how bacteria covered in soot or something like that can actually be pushed out of the solar system and into other solar systems purely by the force of the sun. And he was saying, that's a real mechanism for panspermia across the entire galaxy, and that we should be looking into whether we've actually already had an alien invasion, because he was saying what a brilliant way of sending your information around with these kind of bacteria-sized spaceships, essentially.
Panspermia has a bad reputation because it's obviously it tends to get kicked in with a lot of alien conspiracy theories, but it is. There's a short list we have for abiogenesis. We got maybe life popped up in tidal pools, maybe it was thermal events, and those are the two most likely, but the idea that it might have originated in space on some comets or another planet that got hit by an asteroid and it flew off there, that is actually on the table as a completely scientific hypothesis. I don't think it's very likely, but it's definitely doable. The issue I tend to have with it is that unless you can show the conditions on Earth back then really did make it impossible for life to form, I would tend to think it would have been easier to form on Earth than in space.
Right, yeah.
But it's definitely on the table as a possibility. I don't think it's too likely, but there's so much more we have to find out. I would love to get some drill samples of Europa and see if there's anything hanging around down on the crust there. But until we start finding other planets that have life or get way better with our biological modeling, we're just kind of guessing and we go for the most realistic option, which is probably those thermal vents on the ocean, but not necessarily.
Have you got anything coming up on your channel that you're really excited about?
Well, next week's episode is Surviving in the Expanse of Space, which is kind of twinned up to the new season of Expanse coming out. And we're going to kind of look at how that makes you have to adapt your lifestyle when you're living on board a ship and see there's some kind of surprises we wouldn't expect. So that will be next week on April 12th. So
yeah, definitely look out for that. You really are one of our favourite YouTube channels. We get a lot of our ideas from you. There's so much stuff. I can't quite understand how you're able to keep up and read so much and keep up on all the science fiction, keep up on all the science fact. It's
lots of coffee and insomnia.
Thanks very much for joining us.
Thanks for having me on.
It's been an absolute pleasure. Thank you very much, Isaac.
Okay, mind sufficiently blown. What a legend.
What a brilliant legend. You must go and watch his YouTube channel.
Everyone subscribe, please.
Jamie.
Yeah?
I stumbled while looking at Venus. I stumbled on something that I never knew before.
Go on.
Have you ever heard of Neith?
No.
So I thought this would be our good space fact of the week. Neith.
Here we go.
Neith is a hypothetical natural satellite of Venus. So the great Giovanni Cassini, not the spacecraft, but the person that the spacecraft was named after, in 1672, basically observed a moon of Venus. And from that point, it was observed 30 more times by quite a few famous astronomers of the day. Although it was never spotted during the transit of Venus in 1761 and 1769. So it was a bit odd. And William Herschel, the great William Herschel, also tried to spot it but never could. But Cassini reckoned it was 1/4 the diameter of Venus. And then Lagrange, the great Lagrange...
Oh, your favourite.
My fave. Announced that Neith's orbital plane was perpendicular to the ecliptic. So he waded in and was sort of, this is cool.
Do you think that's what he said at the time?
He went, this is cool. I reckon there's a moon of Venus. So back in the late 18th century, there was a debate going on about whether Venus had a moon or not. People said, nah, it doesn't. It's just that Venus is so bright that the image of Venus is reflected from the telescope to the back of the eye and back out again, so you see this secondary image. That was one explanation. Then it turned out that a lot of people started looking at it and say, well, these observations of a bright moon coincide with where stars probably would have been. So, as we know, Venus, unfortunately, doesn't have a moon.
Oh, well, look, it tried.
Yeah, and in 2006, there was a study about why Venus doesn't have a moon.
Oh.
And this is actually quite cool. Alex Alemi and David Stevenson basically did some form of, I guess, a simulation of at California Institute of Technology. Caltech.
Swear all the cool people are out.
And it said Venus likely had at least one moon created by a huge impact billions of years ago, and then 10 million years later, another impact reversed the planet's spin and caused the Venusian moon to gradually to spiral inwards and to collide with Venus.
Oof.
Yeah, and if later impacts created moons, these were removed in the same way.
Jeez Louise.
It might be that it's too close to the sun, and so the strong solar tides destabilize large satellites. So how lucky are we that we've got this great big moon?
The cosmic ballet goes on. Just throwing in golden nuggets.
What should people be doing after they've listened to this podcast, Jamie? Do you know what I reckon? I reckon they should just relax with a nice cup of tea. But what do you reckon?
You could, but before you did that, think how much better that cup of tea would be, Matt, if you had gone to our podcast page, subscribed, job one. Number two, gone over to iTunes, given us a lovely 5-star review.
Yeah,
I mean, we're not putting words into your mouth. Just tell us how you felt, and then you could go over and check out our merch store, get yourself some t-shirts or some mugs.
Oh yes,
and then if you really liked it, and you think, well, they're just doing this for free, how can I help? Maybe you could give a couple of bucks a month on our Patreon page. Are we worth the price of a cup of tea a month? So that's what I want you all to ask yourselves.
You could perhaps go on a diet. Maybe if you buy a Mars bar every day, forgo the Mars bar, and with the money you save,
learn about Mars.
In some ways, if we were a pub, you'd be standing at the Mars bar.
Oh, God. Matt, people were about to subscribe and give us money, and you just ruined it. You f***ed it up. Matt, I'd like to wish you and our listeners a really great weekend.
I would like for you to have a great weekend as well, Jamie.
Oh, thanks, Matt. Thank you.
And listeners, thanks very much for tuning in.
Make sure you listen to next week's.
Next week's going to be a humdinger.
I mean, they all are, but I'll tell you what, 77 is going to be vintage, I think.
Vint Poddy. Or
77, God, we're getting through them, aren't we?
Sure are. Oh, anyway, it's time to go. Let's let these people get on with their lives.
All right.
I hope you had a pleasant commute into work, or maybe a lovely cigar while you listen to this podcast. And
maybe you've gone for a jog.
Yes.
Like our mate Hot John, who doesn't like being hot.
Or maybe you're spooning baby food into your young child's mouth.
Or your old child's mouth.
Yes. That'd be a bit weird. Anyway, bye-bye, podcasts.
Goodbye.
Bye-bye. See you soon, bye.